Hello everyone, let's look at the following problem. Again, we have two objects, A and B. The first object that will start to fall, it's object A with initial velocity towards the ground, magnitude of 10 meters per second. And after 3 seconds, object B will join the journey. However, I do not know, or we do not know, the initial velocity of object B, but we do know that they will have the same position of 10 meters, okay, above the ground. Okay, so we need to find this velocity. So let's build again function of position for two objects. We need to understand that if object A has the time travel of t, then object B has time travel of t minus 3 seconds, okay? Because he will join the journey only after 3 seconds. That's why he will travel 3 seconds less. Okay. Now, I'm gonna use again the following formula. Initial position plus initial velocity times t plus acceleration divided by 2 times t squared. Okay, this is the formula that we're going to use to build our function of position. Okay, so initial position of object A is 200 meters above the ground, and initial velocity minus 10, okay, and of course gravitational acceleration of minus 10 divided by 2 times t squared. And this is our function of position for object A. Now let's build the same, or let's do the same for object B. Initial position is 0, okay, here, because he began to move from the ground. Initial velocity we need to find, and again, instead of t, we need to use t minus 3 seconds. Also here, t minus 3 squared. And this is our function of position for object B. Now it is given that they will pass each other when they have the same position of 10 meters above the ground, which means we can use this expression or function of position so that we can calculate the time that took to object A, okay, to move from this point to this point. Why I will not use this expression or function? Because, okay, let's assume that I will use it at the beginning. 10 equals v0b, initial velocity of object B, times t minus 3 minus 5 times t minus 3 squared. The problem with we have two unknowns. We don't know the time and we do not know the initial velocity. Okay, that's why I will not use, at least now, this function to calculate the time. But if I'm going to use this function of object A, okay, we will have only one unknown, which is time. Okay, so let's calculate it. We will substitute instead of xa by 10, okay, and there's some mathematical steps, okay, that will give us this expression. And then you can use also calculators to find two values of time. One will give you positive value and the second will give you negative value. We're going to use, of course, positive value, okay, and this is time, okay, that took to object A, okay, very important, object A, to travel from initial point to 10 meters above the ground when they pass each other, and this is the time that it took. Now we're gonna substitute, okay, when we're gonna use second function of position for object B, we're gonna use this time of 5.25 seconds, and we're gonna substitute here and of course here. But also we know that when this time equals to 5.25 seconds, the position of object B also 10 meters, okay? So 5.25 minus 3 will give us 2.25. Here will be squared, okay? And then we will get this expression. Now you can take your calculators and you will get something like 15.7 meters per second. This is question A, okay? So if object B will be thrown straight up with this velocity, okay, they will pass each other at the same position of 10 meters above the ground. Okay, question B. What is the velocity of object B if they pass each other 1 second after object B thrown straight up? Which means it is given that object B, okay, starts to travel, okay, after 3 seconds when A starts to travel. Now it is given that they will pass each other 1 second after object B started to go up, which means that time travel of object A is 4 seconds, okay, 4 seconds. Now the difference between question A and B, in question A we knew the position, okay, the same position. Now we know that the time, okay, so we're gonna use again this time of 4 seconds. We will use function of position of object A and we'll substitute t by 4 seconds here and here, and therefore we can find where they're actually gonna meet each other, okay? And after this, okay, we're gonna use this expression or function of position for object B. We will substitute xb by the value that we will find here, and also instead of t we'll use 4 seconds. Okay, let's see the solution. So by using this function of position for object A and t when t equals 4, okay, will give us 80 meters above the ground. This is a new position, okay, for this question B when they pass each other, okay? So now we're gonna use 4 seconds and 80 meters and we'll substitute it here and here, okay, when this function, this function is actually a position function of object B. Okay, 4 minus 3 equals 1, okay, this is initial position, initial velocity of object B times 1 is just v0b, minus 5, okay, and finally we get that velocity of object B should be 85 meters per second, okay, and they will meet at this position. I guess that's it. Okay, I'm gonna see you in the next problems. Thank you very much. Bye bye.